Hello there and welcome to the second tutorial on direct problem solving for tree data structure. So over here I have a question from leetcode, which is average of levels in binary tree. It is an easy question and has a successful submission rate of 69%. So what we are supposed to do is we are supposed to return a list that contains the average of node values in each level of the tree. So how do we do that? We will use breadth first search because it is intuitive, and of course it does the level traversal. So while we will be doing the level traversal, we will try to uh, collect the node values and store and obtain the average values and store them in the form of a list and ultimately return that as the output. So before we code, let's understand the flow of what we are going to do. The task is to do the average of levels in binary tree. So, of course, levels, that is level order traversal, that is breadth first search. So what we will do is for a level, these are the three levels for this tree. And for each level, what we will do is we will define level sum and n, that will be a node count. So for this level, the level sum is 3 and node count is 1. And these two will give us the average of the level equal to 3 by 1. Similarly, from here we will get node sum as 9 plus 20 equal to 29, node count as 2, and from here we will get average as 29 by 2, which will be, by the way, 14.5. Now from here we will get the level sum as 15 plus 7, which is 22, and node as number of nodes as 2, and these together will give us the average as 22 by 2, which is nothing but 11. And now there we will create an answer array which will store these values in the form of a list. So 3, 14.5, 11, and this is what the output is needed. So what we will do is we will return this list. So this will be our final answer. So this is what we are going to do. Let's hop back to our editor or the computer and do it over there. So let's finish this. Q for breadth first search, it's required. Level equal to 0 to keep track of level at which height we are on the tree. Answer equal to empty list. This will contain the answer. While Q, the typical loop of breadth first search, I want to count the node count. That is, node count will count the number of nodes on the level we are at. Then I want to do level plus 1 here, and I want to make another loop that will perform the breadth first search in that level, in that height. So we will be, whatever happens here is happening inside that level from left to right. So we have popped the node, and of course it is a queue, so pop 0. And I need to do sum here. So before I enter the level, not here, but somewhere here, before I enter a level, I want to initialize a variable, let's say level sum. So this variable will be level sum and it will be 0 for now. And inside this level, as I iterate over the nodes from breadth first, that is left to right, I want to do is level sum plus equal to node.val. So this will basically collect the sum of all the nodes. And then if there is a left child, I want to append it to our queue. If there is a right child, append it to our queue. Typical breadth first search again. Now, after the level traversal is done, I want to append it or append this average value to our answer. So outside the loop, where outside the node count loop, here I will append the value, the average, to our answer array. That will be sum divided by the number of node counts in that level. So let's say it's n. So I need to define n, right? What is the number of, what were the number of nodes in that level? So over here I will define n equal to node count, just a copy of node count, because in the below loop we are decrementing it and losing what originally it was. So now I can use n over here. So it is basically returning me the average value, which is, average is nothing but sum upon number of elements n. And outside the queue loop, I want to simply return the answer. Now I will run and check if there is any syntax error or any error. No, it's perfect. Submit. And that is it. So it works fine, and we performed the breadth first search to solve this problem, and it was in fact very breadth first search based problem. So with this we are done.